Now that we've had some practice converting polar points to rectangular points and rectangular points to polar points, I thought we would do some practice on converting rectangular equations to polar equations. So that's what we're going to do in this video. Here we've got this rectangular equation, 3x plus 2y equals 6. Now we know in the rectangular world, 3x plus 2y equals 6, that's a linear equation. But let's see what this linear equation looks like in polar form. To convert equations from rectangular form to polar form, again, we're going to use the facts that x is equal to r cos theta and y is equal to r sine theta. So everywhere we see an x, we're going to plug in r cos theta. And everywhere we see a y, we're going to plug in r sine theta. And that is equal to 6. Now in the polar world, when we write an equation, we want to write it with the r isolated by itself on one side of the equation. So, typically when we write functions in function form, we write f of x on one side or y on one side. In the polar world, when we write polar equations, we want to isolate r by itself. So here in this example, we have 3r cos theta plus 2r sine theta is equal to 6. Notice that both of the terms on the left side of this equation have a factor of r. So I'm going to factor in r from each of these terms on the left side. That's going to give us r times 3 cos theta plus 2 sine theta. And that's equal to 6. And now all we have to do is divide both sides by 3 cos theta plus 2 sine theta to isolate r by itself. So we'll have r is equal to 6 divided by 3 cos theta plus 2 sine theta. So in the polar world, this linear equation is r equals 6 divided by 3 cos theta plus 2 sine theta. All right, here we're asked to convert x squared plus the difference y minus 3 squared equals 9, and we want to convert that into polar form. So again, everywhere I see an x, I'm going to put r cos theta, and everywhere I see a y, I'm going to put r sine theta. But first here, I think I'm going to simplify the left side of this equation by going ahead and squaring the difference y minus 3. So if we square the difference of y minus 3, we will have x squared plus y squared minus 6y plus 9 on the left side of our equation equal to 9 on the right side of the equation. And I notice here that if I subtract 9 from both sides of this equation, the 9's cancel out. So that'll leave me with x squared plus y squared minus 6y equals 0. Now I'm going to go ahead and do my substitution. X squared is the same thing as r cos theta squared plus y squared is the same thing as r sine theta squared minus 6 times y is times r sine theta. And that's still equal to 0. Let's square the first term. That'll give us r squared cos squared theta plus squaring the second term gives us r squared sine squared theta, and we still have minus 6 r sine theta equals 0. Now here in my first two terms, I notice I have a cosine squared theta plus a sine squared theta. And each of those terms have a factor of r squared. So I'm going to factor out an r squared from each of those first two terms. We'll have r squared times cosine squared theta plus sine squared theta minus 6r sine theta. And that's still equal to 0. And now I notice that cosine squared of theta plus sine squared of theta, well, that's a Pythagorean identity, and cosine squared of theta plus sine squared of theta is equal to 1. So really we have r squared times 1, which is just r squared. So now we have r squared minus 6r sine theta equals 0. Each term on the left has a factor of r. So again, I'm going to factor out an r from each term on the left. Factoring an r from r squared leaves me with r, and factoring an r from minus 6r sine of theta leaves me with minus 6 sine of theta, and that is equal to 0. Now, if we set each of these factors equal to 0 and solve, we'll get r equals 0, and we'll get r is equal to 6 sine of theta. Now, it's at this point that we have to have a little bit of math wisdom or intuition, because we have two different equations. We have r equals 0, and we have r equals 6 sine theta. Well, if we look at r equals 0 is a single point in the polar plane. And that single point cannot be the same as x squared plus the difference y minus 3 squared equals 9. X squared plus y minus 3 squared equals 9 is the graph of a circle. R equals 0 is the graph of a single point. So r equals 0 is not going to be the equation that we're looking for. That means that r equals 6 sine theta is the equation that we're looking for. And as it turns out, r equals 0 is just a point on the graph of r equals 6 sine theta.